Hi, chat. Oh, I forgot to turn my light on. Welcome to the last day of AOC. Day 25 is about to start in 4 minutes. I am not set up, so we got to do that real quick. But it's the last day, so you know what that means. Spoilers. Let's get this all ready to go. What is the thing called? Ah, I see. So we submit part 1 and then we do AOC 25 part 2. So we're all ready to go there. I gotta actually open up the browser. Don't have that open. But Tech Tuner was first today. Hello, Tech Tuner. Welcome to the stream. We've also got JJMC, of course, and Beldothis. Good to see you. And we're about to finish this sand, whatever, rain. I don't even know what this is supposed to be. I didn't read the lore. Oh, we're forcing snow? Oh. We're climate changing? Ramon, hello. Walker Codes is also here. Yeah, we didn't do too many of them night of. But yeah, we did 12 night of. We did 7. And we did 2 and 3. And we're gonna do 25. Hooray! It's still a decent rank on this one, given how late I did it. And well, this one, but a lot of people didn't get that one done. But yeah, good luck to everyone who's solving today. I know people often mute up right around now. Oh, actually, I'm supposed to press enter here, and then this to get that going. Right, it's been so long since I've done one of these live that I forgot how it works. But that should get us in a good spot. Yeah, this ASC was a little bit different for me because I didn't do as many of them live, but still had fun with it. No points unless we get points tonight, but I'm not gonna count on that. Although I will make up some time on part 2 as I usually do. But yeah, we'll see how it goes. Good luck to everyone who is solving, and I am glad every year that Eric puts this together. And I always have fun with it, so I hope you did too. I still need to go back and finish some of the years. Like I don't think I've done 2015 or 2016. I think I've started both of them, but not actually completed, so maybe there will be some of that in the future. I still have my little cube from last year still on my desk. But this song's looping, so we'll go on to the next one. But good luck, everyone, and I will see you on the other side on today's solve. Let's go. Alright. Lettery things. Day 235, off to a bad start. Okay. Components. It looks like a graph. List of other components. If you disconnect the wire between this, the wire between this and that, you'll divide the component into 2 separate disconnected groups. Find 3 wires needed to disconnect in order to divide the components into 2 groups. Oh. I don't know how to do that. Hey, what's up, Ethan? Hello. Yeah, I don't quite know how to do that. I guess it's gonna always be one of these ones that's only 1. But let's see. Let's just parse everything and go for it. For line in s dot split lines, source this equals line dot split on colon space. Nodes source equals dests dot split. Oh, I guess we don't need default dict because we're just doing that. Okay, so that's parsing. I guess we can just try. We can try severing these. Because I think it has to be one of these, right? What did it say? HFZ PZL. Who the fuck is HFZ? HFZ? HFX? Oh. So it is not necessarily that one. Oh, you have to disconnect 3 wires. Oh, God. Well, we could just make the graphs. I don't even know how to figure out clusterings. How many wires are there? A lot. We could just brute force it. Let's see how many we would get. How many possible cases there are. 3,000. Okay, brute forcing actually isn't that terrible. Are these directed components? Connections aren't directional. Okay, so we actually need to reverse these as well. So we will go back to collections. I guess we'll represent these in one direction though. Here. Okay. Yeah. And then we need to choose 3 from that. Yeah. Or FBCC, hello, welcome. J plus 1. We're gonna cut them and then find the number of connected components. The set is probably better here. Wait, how do we find connected components? I guess we find a node. We find a node and then we color it, I guess? I guess we just delete nodes from the graph. And to take out a node, we need to remove it from all of its things. This can probably be wall nodes because we're going to remove nodes. And we're going to remove all of its connections. So for node in nodes node processing.append node, and we'll do nodes for other. Try to process those nodes other dot remove node, then del nodes node, and then ret.append len of done. Oh, we gotta put this into done. Might work. Hmm. 247. 13 and 19. That is not correct. Here we go. Gonna be kind of slow, but I think it should get there. So what it's doing. Oh, that's way too big of a number. Yeah, no, this brute force is not going to succeed. Huh. So we gotta be smart about this. Hmm. Hey, what's up, 901ish? Yeah, that is too many. It's gonna take way too long to get this. Even though it's actually this, which is still way too big. I don't know enough about graphs. How do we know when a node represents an interesting connection? Like, we kind of have to figure out clusterings. I wonder if as we build this, we figure out how connected things are. I actually don't know. I'm not good at graphs. But this is brute force, which works great for the sample. So now we need to iterate on that, come up with a better answer. Huh. Do you know things about graphs? uh, sad. I've ruined Christmas. Yeah. Yeah, I wonder if it's like take two arbitrary nodes in a graph and find where they meet each other. Find how many ways they meet each other, how many paths to each other. Um. Maybe? But I have to make 3 cuts to separate the graph. So my guess is it's like 2 big clusters, and then there's like 3 things in the middle that connect them all. I could figure out how to make a dot graph. It has to be exactly 3. It has to be exactly 3. What is the... Oh god. Why do I feel like the syntax for dot is nuts? Dot bidirectional arrow. I don't want that ugly thing. Dir equals both. We're gonna do something very dumb. For AV in connections S, print A V dir equals both. No. I don't know that that would help though, because it could be like degree 8, but 8 connections in the middle and then just 1 to the other side. This is how this works. Why did it whir so much? Oh, I see. Because it is a rat's nest. I was hoping dot would like sequester the 2 chunks. Oh wait, maybe it does? Oh! Okay, we found one of them. GQR? This is the jankiest way to do this. Fucking A, what was it? VBK. That's one of them. No, it's not %3. KLJSCR. Use your tools, I guess. SDV MXV. Alright, those are our 3. One's the suburb. Can source dot remove test. Oh shit. Hey, what's up, Andrew Next? Good to see you again. Oh, I gotta get rid of my dot prints. That's not the right answer. But we found them! Oh, I wonder if we got the wrong number of connected components. Ah. But surely it's just those three, right? Where was the little break in the middle? GQR VBK, yeah. KLJ SCR. SDV MXV. Huh. I mean, those feel like those are the three. There's big giant cluster over here and big giant cluster over there. So what the fuck gives? Look, I plotted it with dot, and there's 3 lines in the middle. Yeah, it's a graph display library. I don't know. Because GQR is definitely a connected component in there, and there's this mess over here. Yeah. Yeah, it tries to reduce the amount of, like, garbage you see. Newport says looks good to me, right? That's not correct. Well, in my graph thing shows that there's only one connected component after doing all that too. Although wait, it had 1,493. How many? Oh my god. Yeah. White space is literally killing me. Drunk Time Lord, hello, hello. How you doing? Hooray! I'm done with AOC. Merry Christmas, Drunk Time Lord. We'll see how I did not get points for any days this year. This is definitely a cheese. This is definitely a big cheese. Let's just say it doesn't exactly work like that. And spoilers. Okay. Oh look, I made up 80 points on 80 spots on the ranking there. Uh. Yeah, I'll learn how this is actually supposed to work later. What is MyPy unhappy with? Oh, because I said list stir. Yeah. Set stir. I don't know why it didn't. Oh, I guess because remove is also a list method. You meet up 20 places on part 2? Nice, nice. How do you actually solve this problem, build out this? Now that I'm willing to get hints because this is my solution. And I'm okay admitting I'm wrong and trying to learn. Network X goes burr? Oh. That's also a graph library that does things for you? Hmm. Let's see. Feel like there's got to be some algorithm about actual network partitions and did anyone actually solve it programmatically? I feel kind of bad choosing it, but I also feel like, oh, it's kind of a creative solution to just fucking graph it and then figure it out. I will say that I have not solved any of them using dot before, so it feels kind of fun. But I might also just go to bed and not think about it too much. Fuck it, we sleep. What is the problem? Basically there are 2 large clusterings of graph nodes, and there are 3 cut points that you're supposed to find, cut them, and then the size of those 2 graphs. I want to suppose, but there's one algorithm that they're looking for here. Python folks get it for free, but I'm trying to implement it in Go. The only one I can think of in Python that's definitely for free is topological sort, but I don't know what that means. Ask AI? No. Fuck you. No. Never. I don't think it's this, but and I'm pretty sure this library only has topological sort. Free as in an easy import? Oh. Whoa, this is a nifty dude. Yeah, Network X is the one that Build Authis used. But I also don't know. Bridges sounds like a thing. Bridge finding algorithm. What does that mean? What do you know bridges in a graph? A bridge in a graph is an edge whose removal causes the number of connected components of the graph to increase. A bridge is a cut that does not belong to any cycle. Bridges are also known as cut edges, isthmuses, or cut arcs. You need to find N bridges, though. Good text auto-corrected like a ghost, yeah. You should come to PyCon. I'm planning to come to US. K-edge connected graph. Oh, you have found link for me. Minimum edge cut. Oh, outside of the US because you can't get a visa? Maybe. I wonder if you find any arbitrary, well, I feel like if you find 2 points and just try and path to each of them and look at their set of edges and get lucky that you find one that has just that overlap. I don't fucking get lucky, yeah. This is a flow-based implementation of minimum edge cut. For undirected graphs, the algorithm works by finding a small dominating set of nodes of G and computing the maximum flow between arbitrary nodes. Yeah, I'm graphs, man. I don't fucking know. Minimum edge cut sounds like a leak code problem. Yeah, it sounds like sounds like shit I'm not gonna figure out, and I'm okay with that. I know some of those words, says we Tommy. Exactly. All right, well that's gonna wrap us up for this year of Advent of Code. I had fun. I feel like I, didn't find the intended solution to this, but I don't know. Good enough for me. Use the tools that I sort of knew, and they worked out for me. Yes, hovering over a title text in Firefox was my solution. But yeah, that's gonna wrap us up for this year. Maybe not streams this year, but we'll see. Yeah, check out the YouTubes and the VODs YouTubes, and I did click record this time, so I don't have to edit a second fucking video today and get demonetized on the other one because it's gonna have background music. But yeah, go hang out in the Discord. I'll see you around. Let's go find someone to raid.